Now let us proceed to joint E. Now at joint E, so we have the members are CE, and that is in compression 4.619. Then we have your DE, also in compression 3.464 kilonewton. Then we have your BE, and then we now have your EF. Now, so summation of forces vertical is equal to 0. Upward forces positive. So the vertical component of EF is EF sine of 60 minus the vertical component of CE is 4.619 sine of 60. And the vertical component of DE is 3.464 sine of 60. So your EF is equal to 8.083 kilonewton. So we get a positive value, hence the assumed direction is correct, and that is in compression. Now, summation of forces horizontal is equal to 0, to the right forces positive. We have minus BE plus the horizontal component of CE, 4.619 cosine of 60 degrees, minus the horizontal component of BE, which is 3.464 cosine of 60 degrees, plus the horizontal component of EF, which is EF cosine of 60 degrees. So your BE is now equal to 4.619 kilonewton. So we get a positive value, the assumed direction is correct, and that is in tension. Now, at joint, let us proceed now to joint D. So we have your BC is in compression, and that is equal to 1.155 kilonewton. So your BE is in tension, so it goes away from the joint, that is 4.619. So we have your AB, and your AB is making an angle of 60 degrees with the horizontal. And then we now have your BF, also making an angle of 60 degrees with the horizontal. Now, summation of forces horizontal is equal to 0, to the right forces positive. Now, the horizontal component of AB is AB cosine of 60 degrees, minus the horizontal component of BF, BF cosine of 60, minus the horizontal component of BC, which is 1.155 cosine of 60 degrees, plus the BE, which is 4.619. Okay, so we have 0.5 AB minus 0.5 BF plus 4.0415, the algebraic sum of the two, and that is now equal to 0. So we now have your equation 1. Now, next, summation of forces vertical is equal to 0. We have upward forces positive. The vertical component of AB is positive AB. Multiply this one by sine of 60 degrees. Okay, plus the vertical component of BF. So we now have BF sine of 60 degrees minus the vertical component of BC, which is 1.155. We have sine of 60 degrees, and that one is equal to 0. That is equal to 0. So we have your So we have your AB. Now sine of 60 is 0.866 AB plus 0.866 BF minus 1.155 sine of 60 degrees. And 1.155 sine of 60 degrees is equal to 1. Okay, so minus 1 is now equal to 0. So let us try to solve 1 and 2 simultaneously. Solving equation 1 and equation 2 simultaneously. So we have your equation 1 is, let's try to multiply this by 0.866. So this is equal to 0.5 by 0.866 is 0.433. 0.433 BF. 0.433 AB minus 0.433, that's your BF, and then we have plus 0.866 by this is 3.5 is now equal to 0. So we have equation 2. Let's try to multiply this one by 0.5. So 0.5 of 0.866 is 0.433 AB. And then we have plus 0.433 BF. And then we have minus 0.5 is equal to 0. So let's try to add the two equations. So if you try to add the two equations, then this is now 0.866. 0.866 AB. Okay, so this is equal to 0. And then we now have 3.5. So this is plus 3 is equal to 0. So your 0.866 AB is now equal to negative 3. Hence, your AB is equal to, so the value of AB is now equal to negative minus 3.464 newtons. Okay, therefore, your AB in here is equal to 3.464 newtons. Since we get a past negative value, hence the assumed direction of AB is wrong. Therefore, your AB should be in tension. Okay, so let us try to substitute AB in either equation 1 or equation 2. So we now have from equation 1, so your equation 1 is 0.5 and the value of AB is negative. So that is negative. So we're going to get the negative sign in here because that is our assumption in this equation. So minus 3.464 minus 0.5 BF plus 4.0415 is equal to 0. It is equal to 0. Hence, we now have so this is so solving for BF. So your BF is now equal to 4.619. So it's 4.619 newtons. We get a positive value, hence the assumed direction of BF is correct, and that one is in compression. Now, we know now the value of BF and the bar force in member AB. So, the only unknown bar force is now your AF. So, your AB in here is in tension, and therefore it goes away from the joint. And this makes an angle of 60 degrees with the horizontal. So we have your A horizontal, we solve A horizontal, and that one is equal to 0. So this is your A horizontal. So the horizontal reaction at point A, and that one is equal to 0. Now, we have your A vertical. So, this is now your A vertical. And we have your AF. This is now your AF. Now, let us try to get summation of forces horizontal is equal to 0 to the right forces positive. So, minus AF plus the horizontal component of AB, and the horizontal component of AB is 3.464 cosine of 60 degrees is equal to 0. So, the value of AF is now equal to 1.732 kilonewtons. Again, we get a positive value, hence the assumed direction of AF is correct, and that is in compression. Okay, so AF is now determined. So we now have the different forces on the different members of the given truss. Tabulate now the result. Okay, so let us try to calculate the force in members. So let's try to calculate now the force in members DE. Okay, so the force in members DE, DF. So this is your point F. So that is now your DF. So this is a joint. Joint. So that one in there is a joint. DF and EF of the scissors truss shown. So we have 800 pounds and we have your 400 pounds. So this truss is supported by a hinge at point A. So we have your A vertical. So this is now your A vertical. And then we also have the reaction, which is now your A horizontal. So this is your A horizontal. Now this is a roller. So we have your reaction is perpendicular to the roller. So that this is now your E vertical. Okay, so let us try to determine now the this one in here is 4 feet. So let us try to determine the value of Z in here. So we have this one is 4 feet, and then we have so this is at the center. So we have so I'm just going to consider this one in here is now your Z, and this is your Y, this is your 4 feet, this is your A, and this is now your point C. So that if you will going to get cosine, this angle in here is now equal to 60 degrees. So we have 30 and 30. So cosine of 60 degrees is now equal to 4 all over Z. So the value of Z is 4 over cosine of 60 degrees, and that one is now equal to 8. So your Z in here is equal to 8 feet. Now, this load, 800 pound load, is 90 degrees with member A, B, C. Similarly, this is 90 degrees with member A, B. So we have also 90 degrees. So if this is 8, now this is at the center. So this is now equal to 4 feet. And this is also equal to 4 feet. So the length of AB is equal to 4 feet. The length of BC is also equal to 4 feet. Now, summation of moment about point A is equal to 0. Summation of moment about A is equal to 0. Counterclockwise moment positive. So your EV, multiply this one by the moment arm A. Then we have minus 400. The moment arm is 4. So that is perpendicular. Minus 800. The moment arm is equal to 8. And this one is equal to 0. So that the value of E vertical is now equal to 1,000 pounds. Okay, so this is going upward. Now, let us now proceed to joint E. So if you proceed to joint E, there are only two unknown members. You have your EF and your DE. So we have at joint E. So this is now at joint E. So we have Okay, so we have your E vertical, and that one is equal to 1,000 pounds. Your EF, this is now your EF. So your EF is making an angle of 30 degrees with the horizontal. This is your EF. And we also have your DE. Now, I am going to assume DE to be in compression. So this is your DE. And assume EF to be in tension. So we now have your EF. Now, this is equal to 30 degrees. And that one is also equal to 30 degrees. Now, let us try to get summation of forces vertical is equal to 0. Summation of forces vertical is equal to 0. Upward forces positive. So we have the vertical component of DE, that is minus DE. We have sine of 60 degrees. So that one is 60 degrees. Plus the vertical component of EF, which is EF sine of 30 degrees plus 1,000 is equal to 0. 1,000 is now equal to 0. So let us consider this one as the first equation. Next, summation of forces horizontal is equal to 0 to the right forces positive. So the horizontal component of DE, multiply this one by cosine of 30 degrees minus the horizontal component of EF, which is EF cosine of 30 degrees, and that one is equal to 0. So that your EF is now equal to DE cosine of, so EF is equal to DE that is cosine of 60 degrees. So that one, 30 plus 30 is 60 degrees. DE cosine of 60 degrees all over cosine of 30 degrees. So this is now your equation 2. So let us try to substitute equation 2 in equation 1. So substituting minus DE sine of 60 degrees plus EF, which is DE cosine of 60 degrees over cosine of 30 degrees, we have sine of 30 degrees. And then plus 1,000. Plus 1,000 is equal to 0. Hence, you get the algebraic sum of the first two terms, and that is equal to negative 0.57735 DE plus 1,000 is now equal to 0. So your DE is now equal to 1,000 over 0.57735, 1732. So this is equal to 1732.052 pounds. We get a positive value, hence the assumed direction of D is correct. So this is towards the joint, hence that is in compression. Next, let us try to substitute DE. So if you're going to substitute DE in equation 2, so that your EF is now equal to DE is 1732.052 cosine of 60 degrees all over cosine of 30 degrees, so that the value of EF is equal to, so the value of EF therefore is now equal to 1,000 pounds. So this is 1,000 pounds with a positive value. The assumed direction is correct, and that will be in tension. Okay, let us proceed to joint C. So this is now your joint C. Okay, now we have your CD. So I'm going to assume CD to be in compression. So this is now your CD. And we now have your BC, that is in your BC, I'm going to assume that to be in tension. So this is now your BC. So your 800 pounds is perpendicular to member BC. Now, since this is 60, this one is 60, hence this angle is also equal to 60. So this is an equilateral triangle. So if this, the total of this is 60, then this angle in here is equal to 30 degrees. And this angle is also equal to 30 degrees. Hence, the 800, if this one is 60, then the 800, so we now have, okay, so this is 90. So we have 60 in here, that is 90. This one in here, therefore, is equal to 30 degrees. So that one is 30 degrees. Now, summation of forces vertical is equal to 0. Upward forces positive. So we have minus the vertical component of BC, which is BC cosine of 30 degrees. So it is included, the 30 degrees is included in the vertical axis. So we have cosine of 30 degrees. Okay, plus the vertical component of CD, we have cosine of 30 degrees. Minus the vertical component of the 800 pounds, that is 800, that is sine of 30 degrees, because the 30 is included in the horizontal axis. Sine of 30 degrees is equal to 0. So minus 0.866 BC plus 0.866 CD minus 400 is equal to 0. So this is now our first equation. Next, summation of forces horizontal is equal to 0. To the right forces positive. So the horizontal component of BC is minus BC. We have sine of 30 degrees. So the horizontal component of CD is still going to the left. So that is minus CD. We have sine of 30 degrees. And the horizontal component of the 800 pounds is positive 800. This is cosine of 30 degrees, and that one is equal to 0. So we have sine of 30 is 0.5. BC minus 0.5 CD plus 6. Okay, so we have plus. Okay, so 800 cosine of 30 degrees is equal to 692. We have 0.82032. 0.82032. And that one is equal to 0. So this is now your equation 2. Again, let's try to solve 1 and 2 simultaneously. We have equation 1. Let's try to multiply this one by 0.5. So this is our equation 1. So we have your equation 1 is negative 0.433. So that is BC. So 0.5 by 0.866 is plus 0.433 CD minus 400 by 0.5 is equal to 200, and this is equal to 0. We have equation 2. Let's try to multiply this by 0.866. So if you try to multiply this one by 0.866 by 0.5 minus 0.433 BC. So we have minus 0.433, that is CD. And that is plus 0.866 of that is 599. So we have 599.98239. 98239 is equal to 0. So let us try to add the two equations. So if you're going to add the two equations, so we have negative 0.866 BC, that is 0, and that is plus 399.98239 is equal to 0. Hence, your BC is 399.98239 all over 0.866, and this is therefore equal to, so BC is 461.87343 newtons. 87343 newtons. We get a positive value for BC, hence this is in tension. So let us try to substitute BC in equation 1 or equation 2. So from equation 1, 0 minus 0.866, BC is 461.87343 plus 0.866, we have CD minus 400 is equal to 0. Hence, the value of CD is now equal to 923.7. 923.76767 pounds. Now, we are required to determine the bar force in member DE, EF, and DF. Okay, so nakuha na natin ito, tsaka ito. So, nakuha na natin ang EF at saka DE. So, we need to determine your DF. So, how are we going to determine now your DF? So, at this point, let us proceed at joint. Okay, let us try to proceed to joint D. So, proceed to joint D. Okay. Okay. Your CD is 923.767 pounds with a positive value, hence that is in compression. So we now have your CD. So this is now your CD. And your CD is now equal to 923.767 newtons. And your DE is equal to, your DE is also in compression, and this is equal to 1732. So it's equal to 1732 point. 1732.052. Now, I'm going to assume BD to be in compression. So this is your BD. This is your BD. And then we now have your DF to be in tension. This is now your DF. Now, so let's try to determine now the angles. So CD with the horizontal. So this one with the horizontal is 60 degrees. So this is 60 degrees. Your DF with where's DF? Okay. Your DF with the horizontal is 30 degrees. So that one is also equal to 30 degrees. And your DE with the vertical. So this one is 30. So with the vertical, your DE is making an angle of 30 degrees with the vertical. So that is now your FBD at joint D. Summation of forces vertical is equal to 0. Upward forces positive. Your BD has no vertical component because that is directed and along and horizontally, or your BD is directed in the horizontal direction. So we have your DF, so the vertical component is going downward. DF, multiply this one by sine of 30 degrees. 30 degrees is included in the horizontal axis. And then we have plus your DE is 1732.052. So we have cosine of 30 degrees. Minus CD, and CD is 923.767. We now have a sine of 60 degrees is equal to 0. Hence, the value of DF is now equal to 1399.99 pounds. We get a positive value, hence your DF is in tension.